Hello and howdy. Happy Friday, everyone. Welcome to another Angular Air. My name is Alyssa Nicoll, your host for this morning or afternoon, evening, wherever you are in the world. And I'm very excited for our guest of honor today. But before we dive into who's here with us and what we're talking about, just a big shout out because today's episode is brought to you by Progress, creators of Kendo UI for Angular. And I made a very unhinged, beautiful poster while I tell you a little bit about them. They are the creators of Kendo UI for Angular, aka the component library that does exactly what you want on the first try. No ritual sacrifice needed, no Stack Overflow tab explosion, just beautiful performant UI like it's no big deal. So check them out. They've got a lot of different dev tools outside of components as well. But without further ado, welcome to my two panelists, Mike and Justin. How are you guys this morning? I think it's both morning time for both of you. Yes. Maybe not.
No, it's afternoon by 4 minutes and 12 seconds.
Dang it.
But you were really, really close.
Well, it's morning for me by 2 hours and 56 minutes and whatever seconds you said.
Get good, Mike. All right. It's morning for me and Justin.
Wow. I'm not allowed to even respect my own time zone.
Hi, chat. Good to see you. Please drop your unhinged comments or questions. Today's very off the walls. We're doing a double hitter Friday. We've got an afternoon episode coming up in a few hours as well. So it's gonna be crazy. I'm very excited for the vibes. Without further ado, our guest of honor. Oh, you've got a request, Mike?
Yes. Can I see a recreation of the unhinged poster face?
A recreation? Oh, yes. You want me to make
you
this
live? No, I want to see you do it. Yes, thank you.
You got to get your eyes really big. Without further ado, our guest of honor today, Christian. Is it Liebel? I'm in my head. I'm saying Liebel. Hey! Yes.
Yay! Absolutely correct.
Yay! Welcome. How are you doing?
Yeah. Hi. So great to be here. Actually, it's pretty fun. So I guess most American people pronounce it, I think, Liebel. And I live in a town called Limersheim, which most Americans would pronounce as Limersheim. So basically the exact opposite than how it would be correct. So awesome that you got it right directly on the first time. That was pretty cool.
I was 90% sure. I did some German studies, and it's always backwards from what you want to lean towards. So whether the I or the E. But I was like, it could always be, everyone has other preferences also against what is common. So welcome, darling. I'm so excited to dive into the topic. But before we do, can you introduce yourself for those who are new to the community? I know the Angular community is growing a lot these days. And so people may or may not have had the chance to meet you.
Sure. So I'm Chris. I'm an Angular developer for, I don't know, I think I started in 2014, so well over 10 years now. So basically around since the early Angular 2 days, also starting in the old Angular JS days. I'm a GDE for AI and for web development, and we are going to talk about both in today's episode, which I think is very nice, very awesome. Yeah, and basically apart from doing consulting work, which is my normal job, I try to be active in the community as, again, a GDE, but also Microsoft MVP and participant in various W3C working groups and other councils there. So I guess that brings me here today.
You're involved in all the circles. That's amazing.
Yeah, I try to connect the dots.
Oh, I am so grateful you decided to come on today. I know there's been a lot of chatter about this episode in particular. I think it's a really great topic. So I just can't wait to learn from you. I didn't know, I don't want to spoil, because I know you have some beautiful slides created, but I wanted to ask for some basic definitions. So I don't know if you're going to cover that as far as what is WebNN? What is Prompt API? So yeah, are we gonna, am I jumping the gun? Are we gonna cover those things?
We are gonna cover those things.
Excellent, excellent.
Alrighty, then can I start?
Absolutely. I have your slides up. They're beautiful, but let me know if you want them down. I can do either.
Perfect. No, it's absolutely fine. Yeah, cool. So hi everyone. Also hi chat. I try to keep an eye on the chat as well. So if there are any questions, we can also answer them right away. So right as we are live. Yeah, and I want to tell you a little bit more about AI in the browser today. So, I mean, the obvious choice would be just to utilize one of the many cloud services out there to add AI capabilities to your app. But the thing is, you can also do that locally, and it has some very compelling advantages over cloud-based approaches, and I think they're worth a look. Of course, local AI APIs also have their drawbacks, but yeah, I guess we will see them today. So you can decide which way to go for your next AI-based project. So today specifically, I want to show you two technologies. One is WebNN. This is actually a library that you can use to add LLM capabilities to your Angular app. Or for example, Prompt API, which is one of the built-in AI APIs. But again, no worries. We are going to cover all of those terms, and we will see all of the demos. Yeah, basically in tonight's episode. All right, and we are going to start like right away. Okay, so first topic, as I've said, if you would add AI capabilities to your app, what you would normally do is go to OpenAI or Azure OpenAI or Grok or Google Cloud or one of the other like dozen services out there that would help you integrate AI capabilities into your applications. However, there are some drawbacks, and these are that, first of all, you need to have a stable internet connection. So if you are on a plane or on a train or whatever, or live in a let's say, country or maybe area where there's not so great connection speeds, for example, this may significantly impact your experience with those services. Then it's all subject to network latency and server availability. So if, especially like in the early days of ChatGPT, maybe you can remember there was like capacity problems, and basically they just couldn't load handle the load, right? That was basically going to the servers. We sort of have this today, especially with like image generation, right? So if you're generating great posters, let's say, they take like for a really long time because it's has heavy computations in the background, and of course many people want to do their Ghibli style memes and stuff, right? I want to convert the images, create.
Oh, I feel so called out right now. Ouch.
No worries. It's good, right? So people want to do that, and it's great, and it's so funny what you can do with that stuff. I'm also I'm also using it like very often. And the results are also awesome, right? So especially if you have a look at the first versions, let's say, or the first stuff that you could do, it was like, well, you can pretty much see that it's AI. But I think that has changed by now. Actually, to be honest, I wouldn't have necessarily thought that poster was AI generated. Looked super great.
I honestly have been really impressed with just lately. Especially when I'm like, here's what we're going for, especially if you can show it like, like a guiding light, then it's usually very spot on. You've got a lot of hype in the chat though. Smart topics in Angular Air. Thanks, Danny. All right, back to you, Chris.
Thank you. All right, some more drawbacks. Data leaves your device. So basically all of the data that is processed is being sent to a cloud service. That basically also depends on, let's say, the location, right? So I'm from Europe. It's evening here right now, by the way. And so basically there are privacy regulations which basically say that data should be processed locally, and that may also be a problem depending on where you live. And then, of course, you typically need a subscription. So typically all of that stuff is paid per token. So basically, if more and more people use your AI capabilities, you also get a larger bill, so to say, that someone will have to pay at the end. That could be your users.
Question on the data being transferred. When you say it has to be, some regions require it to be processed locally, does locally mean like in that region, or you mean locally on that machine?
In the region. So basically here, let's say in the EU, it's basically that the preference is to also process the data in the EU. All right. But of course, locally is like even better, because in that case, it doesn't even leave your own device. So basically you can ask whatever you like and nobody else will see it. And it's also like, in that case, guaranteed that it will not be used to train a model, for example, right? Mm-hmm. Which you can simply not be sure about when you're using a cloud service. So the question arises, can we run Gen AI models locally? And the answer is yes. And the cool thing is, there are many different ways how you can run AI stuff locally, and I want to show you all of the different ways today. So first of all, there's bring your own AI models. So BYOAI models.
Oh my God, I love this.
Yeah, awesome. There are many cool libraries, WebNN, Transformers.js. There are various frameworks, Onyx Runtime, TensorFlow.js. There's APIs like WebNN and COS. This is like super new, not even an established standard right now. This is basically all in discussion. Then there's built-in AI, BIAI, I guess. And then we have several APIs like writing assistance APIs, translator and language detector APIs, the prompt API. Yeah, that's what we have in that space. And what this exactly means and how they basically, yeah, and where they belong to, so to say, yeah, I will show you that in the demos. So let's start with the first one. That is WebLLM. And that is pretty cool because it is a local runtime for large language models. It's using WebGPU, an API that gives the website low-level access to the GPU. And then, yeah, basically runs calculations. And of course, AI is great for GPUs, or the other way around. GPUs are great for AI workloads. And so you can do that stuff like efficiently and run it locally on your device. Here's a demo. So I'm using Chrome Canary here. WebLLM would also work sorry, I just need to copy the link. Would also work in the normal version of Chrome. So that is actually already pretty stable, not in all browsers yet. But yeah, at least in the Chromium-based browsers, you can perfectly use that stuff. Here you have like a super large library of LLMs that you can use. They are all open weight models, and they are all free. Then you can choose one. Here I basically picked the Llama 3.1 model, like not the latest, but it doesn't matter. And then you can do stuff, right? And do AI inference locally on the machine. So we can ask stuff like, I don't know, tell me a joke. And then when I send this here, this is all being executed locally. You can see that we are loading the model from the cache. It's in the cache of this device. And now basically, here's this great joke. What do you call a fake noodle? It's an impasta. Ha. Incredibly funny.
Can you just give a quick like definition of what the LLM is and like why are you picking which one, right?
That's a great question
for our viewers.
Absolutely. So I forgot about that actually. Yeah. So normal for me already. So LLM is a large language model and is a special kind of generative AI model that can understand and can produce content in natural language. And previously this meant only text, but now this also includes images and speech and yeah, even video. So yeah, that's what LLMs can do. And the models, yeah, basically you can just try them out. So like from a very high level, this number here is relevant. So here we have, like, for example, an 8B model. B stands for billion. And that's the amount of internal parameters. And basically, the rule of thumb is the larger this number is, the better that model gets, the more, let's say, internal knowledge it has. 8B is like super small. So the cloud-based models have like probably hundreds, maybe even thousands of billion parameters. So yeah, these are like the smaller ones. But as you can see, it was perfectly able to tell me a wonderful joke in that case. But of course, it's also like better and actually useful stuff that you can do.
I feel like the name is very deceitful because it's, I assumed like WebLLM, like, oh, it's using like the broader network of things. It's reaching out, taking your data elsewhere. So that was surprising to learn that it's all local. So.
Yep, indeed. Yeah, good question. So indeed, currently it's not connected basically to, let's say, a search tool or something. So it's indeed all local. So I could also basically disconnect now from the internet, which I cannot do now because otherwise the stream would end.
In my head, I was like, "Oh yeah, do that," and then
technically you could do it, but there'd be consequences.
Right. Well, so in the next episode of,
couldn't you do it through DevTools though?
Yeah,
oh,
you're right.
you tell the I got you. Yeah. That makes a lot more.
Fake offline.
Yeah. Good point. So now
he's
we're
like
fake offline.
14 billion. That's his LLM number, right?
All right. Let me just think about another joke. Now we're sending it. You can also see there's no network request, right? So this is directly being run locally. Okay. Wow. No, I'm not gonna even read it.
Can you? So is it downloading that? When you select that LLM, I saw that it like downloads that right locally to then be able to run that.
Yeah, in that case, basically, it was already downloaded, and maybe you've seen it took relatively long to actually even fetch it from the cache. But yes, the first time you would use a model, let's say, I think I didn't use that model, it would have to download it, and then basically it will have to do that in the background. And of course, important to know is that those models are pretty big. So here you can see that's a 2B model, and it is probably a gigabyte when we are finished. Oh no, even more than a gigabyte, 1 point.
So like, do we need to like RMRS this like node modules when we're done playing around with it?
Good question. This all happens on runtime. So basically the npm package is like super small. But yes, during runtime, it can take, again, this was like 1.5 gigabytes. So this would take like super long and basically kill your data plan, right? When you do that on a mobile.
Is this something, those downloads, is that managed by the browser or is that managed by the individual application?
It is managed in that case by the library. So WebNN takes care of downloading that stuff. Yeah.
Okay.
But and it needs to be open. Yeah.
That's fair. But I don't know if it's something as a developer, if I'm utilizing one of these LLMs or depending upon what I make available to my users or I force them into a particular one. Is that something I need to worry about cleaning up, or does WebLLM take care of that?
It doesn't take care of it, no. So basically you have to also, depending on what you want to do, right? Because I guess you wouldn't offer like a chat style interface, but you would have something specific in mind. And then basically you would take care of carefully selecting a model and maybe only make that particular model available.
Excellent.
Yeah. Alrighty, so back to the slides then. So that's WebLLM, and the cool thing is you can embed it like super easily into your Angular applications. Just go to this npm package at mlc-ai/web-llm. You can see size it's already pretty big, so it's 30 megabytes, and then basically it will download like the larger model that is by far larger. When you use that for the first time. This is what we've just seen. So basically, when I use a model, it downloads it from a model repository, that's Hugging Face, downloads it into a local cache, and then basically my website can access it. There is
Hugging
one
Face
issue though. Oh, sorry.
Sarcasm detector?
Yeah, for example, they have many cool.
They have a lot of things? Oh,
yes,
that's the only thing I knew it did. Okay.
I also have a cool demo there. It's also, which I also like.
I thought that was just showing the name of the emoji right there. Right? That's an actual thing.
Oh,
yeah, no.
Oh, sorry.
Yeah.
That's actually the logo. But let's talk about Hugging Face in a good point. In a bit. So basically that's a repository. We are downloading it to the website. The problem is we have the same origin policy on the web. And so this means that we cannot share models across origins. So you've seen that one model was 1.5 gigabytes in size. And SOP says if, like, let's say example.com and example.de want to use the same model, you have to download it twice. And so that is an issue. There's a potential solution to it, but that's something to keep in mind. And that may basically prevent like the broader usage of WebLLM. And to show it basically here is like some sample models along with the sizes. Yeah, if you download like a 70B model, which again is like is way better, of course, than the smaller ones, but it also comes at a cost, in that case, with a huge file size of 40 gigabytes.
I feel like, because you were saying this might be restrictive in being able to use web LLM, but I feel like you would know, okay, a targeted use, and therefore you would know what model you need versus like all of them, right? Like, or is that not necessarily the case?
Yeah, I guess ideally you would just pick one, and also again for your use case. But I will show you some potential use cases also, and then basically you can decide for a model that makes sense. All right, should we have a look at another demo?
Yeah.
Nice. Next cool thing is that's like also a library called transformers.js. And that uses a framework in the background that's called Onyx Runtime to basically run that stuff. And yeah, they also have cool demos. So let's have a look at this. So transformers.js is a little bit different. And that, so WebLLM was about running LLMs, but transformers.js also deals with LLMs, but can also do like other stuff and run that locally in right on your device. And there are pretty cool demos, and I just want to show you like this one, Doodle Dash, where the AI model has to detect what I am drawing. This is like super fun. So that's for your next, I don't know, for the next party. That's pretty good. So I should draw a soccer ball, right? And basically now you are drawing, and it needs to detect like soccer ball. And it worked. Okay, so lantern.
Oh, I see. So the time ends as soon as you've got it close enough.
Right. And okay, cruise ship.
I like seeing what it's predicting right now. That's cool. Like underwear. That's great.
Yeah. Bench, underwear, diving board, ocean.
Oof, that is okay.
No way! You do one dash.
Okay. Oh, this is pretty good. So, okay, nice. Oh, oops. Butterfly.
Very skilled with drawing with the mouse. I like this.
Oh, dragon. Dragon is a hard one. No.
Oh, it's a cute rabbit.
Okay. I guess I'm.
Why does it not know? That was obviously. Oh, it didn't get dragon.
Yeah, unfortunately. So that is where my drawing skills like ended. So dragon was not exactly right. And that's like a fun use also like of AI models. You can see the great one of China again, right? So that was that was the easy one. So that is actually like a quite fun example of stuff that you can do with AI. And basically in the end, that's also the question. So for what cases would I actually use AI? And the answer is like, basically wherever it would be super hard to implement something by using a normal, how would you call it? Normal algorithmic patterns, right? So basically, how would you solve that like with an if and a for loop? So that would be pretty hard to do. Alrighty, so
we kind of think about like what we're trying to solve at almost at like runtime, right? Dynamically at runtime. So we're saying, hey, we've got a user, they're coming to our app. We need to have something happen while they're there at that moment. What are we trying to solve? Typically, we write the code for that. Can we, have that happen dynamically through these models, right? Or through this AI, right?
Yeah, right. Because basically it's also good point. Because basically all of that was like stuff that the AI model could never like guess, right? So basically it's the input was probably this image of a dragon was probably created for the first time ever. Like in the entire universe, probably I was the first one to exactly draw this image. So basically no one could foresee what would happen. And yes, also for those cases, AI makes sense. Okay. Good. That's Transformers.js, another library. And now let's talk about the thing in the title of today's episode, and that is WebNN. WebNN is pretty cool. You may have heard of WebGPU before, and maybe also of WebAssembly. And WebNN is a new API, basically on the same level as WebGPU. We're using WebGPU to get low-level access to the graphics processing unit on our device. And now there's our computers, or more recent computers, are shipped with special accelerators called NPUs, so neural processing units, which are optimized for executing AI workloads, or NN workloads, which is the abbreviation for neural network. In the end, all AI models are neural networks. And so basically, WebNN wants to give us access, low-level access, to the neural processing unit of the device. This is like super new. WebGPU is already in the first browsers. WebNN is not. There's a flag that you basically have to flip in order to use it. It's currently in specification by the WebML working group, like absolutely in flux. Stuff has changed like very frequently. And yeah, implementation is currently in progress in Chromium. And the cool thing is that it gives us a very great performance for specific AI workloads. So basically, you can also use like WebAssembly for AI workloads, and also GPU for AI workloads. Basically, for stuff that is baked into hardware, it just makes sense to call those basically accelerated operators for a very efficient execution of AI inference. That's basically the execution, so to say, of an AI model to get a result. And let's also have a look at that. So that is basically, again, a way of very efficiently running AI models. And we will just directly go to the WebNN website, because they also have this nice chart here, which I really like. Cool thing is, WebAssembly can only target the CPU. WebGPU can only target the GPU. And with WebNN, you can talk to the CPU, the GPU, and that's new, the NPU.
Yes.
And they also have some nice samples. And I really like, let's say, image classification. That's also fun. So this tries to detect something in a camera image. So let's see if it correctly detects this water bottle. Yes, and it does. Awesome. Yeah, very nice. And as you can see, this basically runs with 1,000 frames per second, like approximately. And now let's compare that to like a CPU inference.
Wait. Are you wearing chainmail? Because it said you were wearing chainmail.
Obviously, you got to come on with your chainmail.
And now basically you can see it still detects like,
oh, this is the top
Oh my gosh. But with only 60 FPS, right? So WebNN is like significantly faster. Then basically use the right processing unit, right, for the right job. That's a cool, nice example here. Also like digits classification. So again, stuff that would be super hard to solve. Oh, wait, next, not clear. That would be super hard to solve algorithmically is, okay, great example. Let's try it again. 9, okay, perfect. Right, is super easy to solve using AI models. Because the idea is you feed it with like tons of data, then basically it has an understanding of what a 9 should look like, right? Or what the Great Wall of China should look like. And then basically it can infer with a certain probability what I, as a user, basically.
So
in that case, drew.
WebNN is giving you access to the CPU, the GPU, NPU. Yeah. What kind of like workloads really shine with this deeper like hardware access? Like, is there anything that really comes to mind? Because I'm still a little vague on like the when to pull for this thing, when to reach for this thing.
I would say like on a very general level for all things AI, this is interesting. Okay. And especially as AI models are already moving closer to our devices, I mean, maybe here on I have an iPhone here that runs on runs Apple Intelligence, right? Which is this great email summaries and stuff, or provides the writing tools. That can be backed by let's say faster that NPUs help with faster inference, and yeah, that's the cool thing about WebNN.
Okay, very cool.
All right. If you want to enable that, we can go to about flags. That's the basically
Is Canary the only version that's offering that right now, or are other browsers also?
Yes.
Offering? Okay.
So WebNN is not bleeding edge right now, but it is like still very in an early phase.
It's the bruising edge, not the bleeding edge.
Yeah, so to say.
Did you just make that up?
I did. With AI.
And basically, here are the two flags that you will have to set to enabled, like enables WebNN API and enables experimental WebNN API features. That's the two things that you will have to turn on, and then you can use WebNN on your machine. Currently, it's not enabled by default. So yeah, users will have to proactively do that if they want to try out WebNN. Alrighty. I want to be fair, and so also talk about the drawbacks of local approaches. And here are some drawbacks with the approaches that I've shown you so far. The first thing is that models cannot be shared across origins. And that means, again, if we're using LLMs that are 30 gigabytes in size, if two origins use them, we have to download it twice. So basically 60 gigabytes in that example. This is not great.
And when you say we need it, like the consumer, right, of our, if we put this in our app, and the consumer who's using our app is the one that has to get impacted by this, right? Yep.
But it's just like a one-time download, right? Okay.
Yeah, correct. That's number one. And number two is inference is fast, but cloud inference obviously is much faster, right? Because you can have much bigger, much faster computers there. So it will, or it can, depending on the cloud service. So they can even be faster in certain cloud services. So it will be, like, generally it is slower than cloud-based AI, and also it doesn't reach full native speed because it's still abstracted, right? So WebGPU, WebNN are abstractions for hardware APIs. They are good, but they don't reach like the 100%.
That's good to know, because I would have assumed it would reach native speeds. So that's okay.
It doesn't. It is close. I think it depends on the model, but it's approximately 90%. But again, not 100%. So there's always like this web penalty, so to say, which on the other hand gives us this cross-platform ability, which is good, of course, right? So we love this, but that's the trade-off. And so basically to solve the first point, basically we in that case is Thomas Steiner by Google, and also like Francois Beaufort. Let me just open the explainer so that I'm telling something wrong or mispronounce it. Yeah, Francois Beaufort from Google Chrome, and we came up with this API, which is just a basis for discussion. So there's no implementation commitment. This may not be a final API, but we thought, could we solve this storage problem? And one idea is basically to introduce, like, let's say, a cross-origin storage that uses hashes that you can then share across origins, where you could put in the model once, regardless of the repository, and it would just stick around in other, let's say, if that would be an LLM, and other web LLM users would like to use the same model, then basically they could just, basically grab it from the cross-origin storage. That's the idea. Cross-origins is a problem, right? Because normally we have the same origin policy, and changing that, there need to be good reasons for it. I personally think that sharing or that downloading multiple gigabytes multiple times is not good,
Mm.
and would probably prevent, again, stuff like WebLLM from spreading, right? So that's an idea. Maybe that solves it one day. I don't know. But just that you've heard it, that could be a solution for the first point. And the potential solution for the second point, so full native speed, is the second part, AI. So built in AI in that case. That's an initiative by Google Chrome, where they would give you access to an AI model that is already installed on the device, so on the operating system, or that's already present inside the browser, so to say. And in that case, we share the models across origins, yay, right? And we can use the full performance that we have available locally. Of course, this comes with other drawbacks, because in this case, you cannot pick the model. You will simply have to use the model that you get. So whatever Chrome ships, whatever's present on, I don't know, the iPhone, you will get this model, and you will have to, deal with it. So to say.
I don't know. It just seems worth it, though. that seems worth it. But maybe there's a specific person who's like, I need this, Gemini or Llama, whatever model. I don't know. That seems.
Yeah.
I really like this.
I don't know. I often discuss that stuff with people, and basically whenever I see somebody new and I ask them that, there's a new result. So there's sometimes I think built-in AI is not good, right? So I guess you want to really know what your model is. And then the other day, I think, but it would actually be good to not download it. Yeah, so basically So my opinion still changes like constantly, and I guess time will tell which concept will make more sense, or if we need all of them, right? We will see.
But then you got to ask your users, like, okay, well, what model were you on, right? Like, it's like, what browser did you use to hit our application? So I know like why you had that bug, right? This other user is not working. It's working on my machine, right? So like, probably opens the door from a developer standpoint. You're like, oh man, now I got to know what the user's hitting it with to really debug what's going on.
My caveat is that I haven't explored developing. I've done development using AI to help with writing code, Copilot, and those types of things. I haven't worked with integrating AI into an application for consumer usage or user usage. God, that sounds weird to say. Anyway, I'm wondering the thought process of model selection for that, because you want to be prescriptive of, all right, this is going to be tailored for the needs that I have. Of how do I find a model that's going to best support the business use cases that I'm trying to satisfy with this. So if you have any points on that, that's great. If not, that's obviously something that I would need to research or look into, or whoever's doing that.
No, it's a great question. So basically, whenever you deal with, let's say, natural language processing, understanding, you will quite likely want to use an LLM. Right? So that's basically the decision the first decision that you will have to make. So basically that number demo, right, that does not use an LLM. It's like another neural network. And then basically, depending on what you build, you will have to then see what LLM is best for your use case. And that is best by just trying them out. So basically trying the things that you would like to do and comparing the different models, how they respond. Because also like DeepSeek is a model from China. And so maybe it may also have like other values, right, than the Western world has. Or the training data set may be different. Or let's say political views may be different. So that all is relevant. So in one case, so by now, I think like the LLMs are pretty good in answering or in solving, let's say, general tasks. The first projects that we did was like, we had a project in the German legal space, so to say, and there we used a model that was fine-tuned on German legal texts. And then, of course, that produced much better quality results than like a generalized one. And so you can also see that fine-tuning aspect of it. Maybe you want to use a fine-tuned model for the use case that you want to solve. All right.
I was really hoping for you to say, hey, go to findanllm.com or something like that.
Yeah. I mean, I would really, so there's also benchmarks, right? Yeah. But in the end, you will have to try out the models for yourself. If they help you in your situation, if they solve your business case that you have.
Yeah,
it's like evaluating a new hire, right? Like, put them through an interview.
Ways to like
Absolutely.
automate that so that you don't have to
Absolutely.
like manually test every single model with every single prompt.
That's a great analogy because that's exactly it, right? So you never know. Also, again, don't trust the benchmarks. They are like an indication, but not more, because again, the results may vary depending on your exact use case. Alrighty, APIs. So here in that case, we give you some task-specific APIs, and that are the translator and language detector APIs and the writing assistance APIs. They help you to write, rewrite, and summarize text. And then there's the generic prompt API that then talks to an LLM that is installed locally, and does basically the same thing that WebLLM does, but using that one shared full-speed local model. And I also want to show you that. And there is a great website provided by the Chrome team. There you can see like the different playgrounds. Let's start with Summarizer API, and maybe what we have here. Let's copy that text from the explainer before. We can just enter it here, and then it is generating a summary for us and has created 3 precise points that this text is about. So this is pretty cool. That's also stuff that Apple Intelligence gives you, right? By basically summarizing notifications and emails and stuff. Writer, rewriter, in that case, it would give it like a task and it would write a text about it. Or rewriter is basically uses the text and changes it. Translator and language detection playground is cool. So it can detect what language it is and then also translate it. So let's say it's in German. Guten Abend. Wie geht es euch? So basically it's 100% sure the text is in German, and then you can translate it to, do you speak Spanish by any chance, any one of you? Or any other language that you
Mike
speak?
says a little bit.
Very, very low.
German is the only
Okay.
other one I have. You just took it.
Sorry. So let's try Spanish. Okay, sorry, that's not supported. Then let's do good evening. I'm pretty sure I can also do that and translate this. Yeah, English. Okay. Buenas noches. So I'm just back from Spain, by the way. And I think I've heard that, so this is probably probably right. Okay, that's that one. And then there's the prompt API. And again, that is basically just this chat interface from WebLLM, but built in. So here we can also do the tell a joke demo, submit the prompt, and then we get this great answer. I don't know if this is funny. Probably not so much. But yeah, right? So that is then LLM built in, so to say.
And built into Chrome, right?
To Chromium. So in Chrome, this uses Gemini Nano, and in Edge, this uses Phi, Microsoft's model. So Gemini Nano is Google's model, Phi is Microsoft's model. Okay. And so, but the API doesn't mandate this, so it could be just anything. It could also like be an operating system level model, which we don't have yet. But if that should ever happen, we could simply wire it up to the OS.
Okay.
All right, and that's basically Prompt API. The cool thing is that just recently, Prompt API has gained multimodal capabilities. So it does not only understand text now, but also images. And that is new. And basically, on the long run, maybe it could also support speech or video content or whatever. But currently, it supports text and image as inputs. So you could also, same thing as in ChatGPT, say, what is that in that image, right? Add the image, and then basically it would attempt and detect that for you. The cool thing is that with built-in AI, we don't store it anymore at the website level, but instead on browser or operating system level, just as we know it from Apple Intelligence or Gemini Nano. That is the cool thing about built-in AI. So in this case, full native speed, and the ability to share models across across origins. If you want to use it, also we need to head back to about flags, turn on enables optimization guide on device, and then basically the APIs for Gemini Nano, and then they will become available. Also, there is a cool debug site called about on device internals. Here you can see that my device performance class is very high because you may be on a mobile device, right? So basically this also gives you a classification if it's possible to run that on your device. Gives you some logs, shows you if the model is downloaded, which model it is, and so on. That's all here on that debug site. And there's again a nice NPM package, which I built together with Thomas, which you've heard before. We've built TypeScript definitions, so you can easily use this from your application, from your Angular application, of course, as well. And so basically, and I will show you that in a minute, basically what I want to do is, again, come back to the question, for what exact use cases do I want to use this? And again, it is whenever rule-based algorithms hit the limits, right? So if there's things that would be super hard to describe with an if and a for and so on, other control structures, then we want to use AI models that are trained with lots of data and where we then do the inference to get a result out of them. So basically you do that whenever you want to implement use cases that are difficult or even impossible to implement using the traditional rule-based algorithms. This still means that if you have a problem that can be solved easily, like, I don't know, Fibonacci numbers, you shouldn't ask an LLM to generate them, but simply continue to do rule-based algorithms for them. Because
Are you saying don't reach to AI for every is this your advice, Chris? Don't reach to AI for everything? Is that what I'm hearing?
Yes.
Okay.
Yeah.
Well, you can have AI write the logic that you need to process the Fibonacci number, right? So, and then but you still have like a runtime, have code that you've already written ready to run versus giving it. And I think that's where the neural network part comes in. It's like, I think of it in terms of like, do I really need to, could a neural network solve what I need, right? Like, could I say, like, feed it something and like it makes a decision? Then that fits into this kind of, oh, cool, that's what I want. I don't want to write the code to try and say all these cases and scenarios. I want to feed it to something and have it neural network figure it out.
It's actually awesome that you say it, because that's absolutely true, right? This is basically the big picture of generative AI, of LLMs also, because also coding assistants are backed by LLMs. Because using one to write a rule-based algorithm is something that actually already happens. So if you use ChatGPT, for example, using its reasoning mode, it will know or basically think about that it may not be the best tool to solve that problem and write a Python program, for example, and execute it. And that then get back the results, because it knows that executing stuff using a rule-based algorithm is not only, like, let's say, cheaper, because the computational power is like less significant, but also probably more correct, because LLMs, they improved, but still they suck at maths, right? Because they are text prediction machines.
Yeah, and you have chats backing you up with that. Andre said an LLM is actually terrible at calculating Fibonacci numbers.
Yeah. And so basically in that case, it's good to go back to rule-based algorithms. Now I have some demos, what we can do with like exact specific use cases, and they're all Angular apps. So let me bring them up. The first one is actually a chatbot interface, and I think you see them like all over the place now. So GitHub has it on its main page now. If I log into Microsoft 365, it's directly on the main page. So here I built a to-do application where you can add to-dos, like host a podcast, for example. I'm not hosting, but you know what I mean. And then basically use a chat bot interface to ask questions. So for example, which to-do isn't done yet. And then hopefully it says that pet the dog isn't finished. Awesome. How many done to-dos do I have? Oops. Okay. Sorry, password comes to pop up, and it's 3 done to-dos, and that's all right? You could basically, based on my to-dos, suggest me more, translate them, and so on. That's all stuff that LLMs can do. And so you could also bring that to your users. And again, all locally on this machine. Let me bring over the code here. In that case, this is WebLLM. So here, basically, you initialize an engine with the model, and then pass the prompt inside. So in that case, basically, I just tell the model what to-dos I have, and then you just enter your prompt, and then the LLM does its thing and calculates its answer, and then basically we are writing that answer on the UI, so to say.
Are any of these demos using the cross-origin goodness that you were, or I guess the no cross-origin goodness that you had showed off earlier, or is that just a theory?
What exactly?
It was with the serial number, and it was to solve the origin problem and having to download it multiple times.
Costs, yeah, cross-origin storage. This is WebLLM, so yes, we would have to download the model multiple times. So yes, cross-origin storage API, if it would ever come to life, would indeed help here. All right, that's a very basic example. That's like super basic because that is what LLMs are. They are basically a chat interface. And you can use that, for example, for use cases like this. But chatbot interfaces are boring. And we've seen them way too often now, right? So basically everything is a chatbot now.
Rude, Chris, to the chatbots.
I'm sorry. But I'm more interested in the things like beyond chat boxes. And so let's bring up the next demo. The next demo is a smart form filler. And this means it fills in forms automatically for you. Isn't that great? So here, let's say you want to buy like like a stamp online. Then basically you have to enter like you have an email, right? And so basically you have the address, and now you go to like the website and have to fill in all of the different fields, and it's like super tedious, and you ask yourself, oh, why I'm doing this? So what if you could simply copy the address and then just click paste, and everything would just fill in automatically for you, right? So in that case, it worked perfectly right. It has, well, here's another name in it, right? Let's try Veronica. And so basically okay, something went wrong here. Let me try that again. Okay, whatever. Yeah, so this demo uses Prompt API, as you can see here, and Prompt API currently only works with English text. So basically it refuses dealing with that because it's Spanish or Mexican. Right. But here you can see basically it assigns all of the information correctly. So also categorization is a good use case for an LLM. And in the background, what happens is that here we're using the prompt API. That's this language model.create here. And then we are just sending the prompt to it. So in the background, it's actually still a chat bot and a chat-based interface, right? But this time the use case is different because there's no chat box, and we're using this categorization capability of an LLM. I can also show you the prompt that we are creating. So basically, this is the prompt in the background. It is longer than the other one. In that case, we say, please try to extract the stuff and then give me the info back. In the right
it's
format.
Like natural language prompt in the middle of code is wild. It's wild to me.
And that is really the core, because also if there, and that's very interesting. Oh, that's outrageous for several developers. For some developers I know, right? So they say, how can this is not, but yes. It's real, right? If the LLM behaves wrong, if it gives you wrong responses, you fix it by changing the natural language instructions.
The natural language prompt, which is just I'm
And it could-
envisioning a world where all code is now natural language. Do you think that's where we're going? Like, or no? Do you think we'll always have?
So currently it looks like we need natural language to describe problems, and those problems have to be solved using existing technology. So using the World Wide Web, using JavaScript, using C#, right? So that's what it currently is. That may change though, because like C# and JavaScript and stuff, they are all very verbose. So what if there was a more compact, let's say, format, right? So what if we just compile to, let's say, machine code natively? That could happen at some point.
Yeah. Amazing.
I like to think about it as like we're taking devs and we're putting these little devs into our code, and then they're off and running for the user and answering those questions live. And we ship those little.
I just think it's going to turn into like the best developers are going to be like the best prompt writers. Like now it's going to turn into like how good is your like just basic communication skills? Like
that's 100%, right? Like that's if you can understand, and I think about it in terms of like, I've developed a skill set of how to work with other developers to explain what I need to get done, give them feedback on how to do it, what maybe successful practices to do, and you guide them in that journey. And now if you do that with the AI prompts, like you can be super successful if you know what to ask, how to refine it, and have that conversation. I think that's where we're really going to shine.
Absolutely.
And you also need the context. And that is, at least for now, the good message for developers like us, right? So are we replaced by AI? The thing is, where I see AI failing, like especially in coding assistance, is that it simply doesn't have the context. And so especially for, let's say, business or enterprise apps, you need so much context. That maybe doesn't even fit like the context window of the LLM, because they're also like restricted or limited in what they can process. And that's currently quite good for us, because that's where I often, many times, see them failing, because they simply do not have this context. They didn't take part in the 25 meetings that we had so far to specify the behavior. But yes, this could definitely change, and also means that documentation, right, and requirements engineering in natural language becomes much more important, because in that case we would have that context if it would be written down correctly. And that's the other problem in software engineering. All right, I have one.
Now, if we could only get this thing to figure out names, right, and then we can solve the naming thing, and then we're like set. Just pick a name for me.
Yeah. It also helps me like many times to decide for a name.
Countless times. I reach for it inside and outside of dev. It's really all in the prompt building. How strong is your prompt building?
Yep.
Oh, you said you have another demo? Let's see it, man.
One last. Do we have time for it?
Yeah. I mean, I'm here. I'm here for it.
Awesome.
Boys, if you have to drop, I totally understand and will not.
Perfect. So it's only one last demo. I hope it's quick. I just need to stop screen sharing. Oh, the question is, yes, it will work. So I just have to stop screen sharing for a moment and then return it. And I have to switch also demos, so it won't take long.
Mike.
Start. Okay.
More times than I can count.
Alrighty, so here we are, and I will present screen. Okay, a Chrome tab, and I want to show you this. I will also share the tab audio. Awesome. So this is a German demo. Basically, what it is an insurance form. So it all happens, right? Or you know that. So I don't know. There was you missed. There was a street, right, and there's another car, and basically you have a crash. And so you have this tedious job of filling in the crash form. So again, forms. And so here, in that case, you could basically fill it in yourself, right? Or you could ask a real-time model, and that's a new thing, and that currently is only a cloud thing, so there's no local version for it yet, but it shows where it can go, and there's no chat box here, but instead, it's a speech-based real-time voice model. So let's try that. Hi, how are you?
I'm doing great, thanks.
Can you hear that, by the way? So it works, right? Yeah, okay,
yes,
awesome.
Yes, we can hear it.
Okay, perfect.
She's doing great.
She's doing a great job. Hi, my name is Chris. Okay, and my last name is Liebel.
Here comes the
Perfect.
test.
And I live in Leimersheim. I forgot the postcode. Can you find out the postcode for me?
Could you please let me know the street you live on in Leimersheim?
Yes,
Then I can.
that is Hauptstraße 3.
I just want to point out that you cut her off, and her feelings aren't hurt. Like you're getting right to the solution.
Know that, Justin.
That's true.
Well, she can tell us if she did, but she didn't say anything, so we're good, right?
Great. I've added your address to the form.
Awesome.
What's
Thank
next?
you. Thank you so much. So next, let's go to the site Umstände des Unfalls. Okay, because I'm also like super lazy, right? And so I also don't want to switch pages. I want to have the AI agent do that for me. Oh, I actually want to go to the damages form because that shows the multimodal demo. Here in that case, I can simply upload a file, let's say of that car crash maybe, and then have it detect what is broken. And so here it hopefully tells us that the front of the car, just as we see in the image, was broken. It's an LLM with multimodal capabilities. It understood the front is damaged and basically has correctly filled that in here. And that is basically multimodal real-time models, again, currently only in the cloud, but we have multimodal models already in the browser. And so, yeah, that's going to be super cool. All right, so thank you, AI, for helping me here.
You're welcome. It was my pleasure to assist. If you need anything else, just give me a shout. Have a fantastic day.
Perfect. And that is a real-time multimodal demo. And that's basically where it all can go, right? So this may significantly change the user experience and yeah, how apps work in the future, right? Because you don't need to type stuff in. You don't need to...
I want it across everything though, you know? Like, I don't want each individual company to have to implement it per like site. I just want like Chrome to have it for me. And I never want to touch a mouse or keyboard again. That's my dream.
Yeah. That is, for example, stuff that MCP servers could solve for us, right? So we can connect to various different services. Let me just bring my screen sharing up again, like here, where we can hook AI models and LLMs to various services, like let's say GitHub or to browsers. They can then basically use browsers through Playwright, let's say, and so on. So yes, agentic AI is basically just saying, hey AI, please, I don't know, order a pizza, right? So basically whatever you can imagine is suddenly possible.
I'm very ready for agents. I know there's a lot of hubbub about it, but I'm personally very excited to enable them more and do less tasks that I hate doing.
And the good thing is, I just read a paper by NVIDIA that said that actually small language models, just as the ones that we've seen, right? So like a few billion parameters, they are actually well suited for agentic AI. And that's a good message for local AI people like me.
I want to say you had so many amazing resources, links, things that you showed. If you want to get me like a list, or even if it's just slides and I can pull them out, I want to add that to the description for people afterwards watching so that they can click through and follow along, because there was so much valuable. Like, thank you, Chris. That was amazing.
Absolutely. No worries. I have one last slide, pros and cons.
Yeah, let's do it.
Alrighty, because it basically summarizes everything just nicely. Right. So pros for on-device models: data doesn't leave the browser. Yay, great for privacy, right? For medical use cases and what else you could imagine. High availability is always there, even if you're offline. Low latency, because basically it's limited by your hardware only. It's pretty stable because the API doesn't change, which could happen in theory, right, for third-party services. And low cost, because basically your users will pay because it's executed on their device. Cons are lower response quality. So cloud-based models are much more capable, much faster, also much better, at least now. Right, so also less capable. For example, currently no real-time support on the web, at least. High system requirements, so probably only the hardware that is sold right now is actually good enough for this. Model sizes are large, cannot always be shared, and model initialization and inference are relatively slow. Also, all APIs that we've seen today are super experimental. So yeah, basically results may vary. But what I want to do is really encourage you to try that stuff out. Try out those cool AI APIs in your applications and make your Angular apps a little bit smarter.
Oh my goodness. Absolutely fantastic. Thank you so much. Beautiful. I know this episode is going to be popping once we upload it. So if you have questions in post, I'll try to shoot them over to Chris and get those answered in the comments. But thank you, chat, for being here, keeping it lively. Mike or Justin, do either of you have any picks inside or outside of technology that you want to highlight this week?
No, I just want to call out that the AI in the top corner of your application in that last demo was very helpful. Like it spoke to that, hey, the AI is speaking to you, the AI is listening, and it was pretty. It was a really cool interface, integrating the logo into how you were interacting with it.
Yep. Thank you.
Justin, you got anything? I didn't see if you...
No, I'm just digesting everything, and my brain is like flying around, like what I want to build, what I want to work on. It's awesome.
Mm-hmm.
Yes, it's so cool. I really did want to ask it if it would know how to put my name in there, my last name in there. So.
Oh yeah, Schwartzenberger. Honestly, I wanted you to ask it if you hurt its feelings by cutting it off, but
at the end she was like, "No, it was my pleasure to help you out." So I think it was okay. Yeah.
Yeah.
Chris, do you have anything else that you'd like to highlight? Any resources you want to give a shout out to?
Yeah, it's a German band, Rosenstolz, which I can only recommend. So I was again in Spain this weekend on a plane where I had no internet connection, so I had to listen to my offline playlist. Haven't listened to that band in a long time, but it is awesome. So Rosenstolz it is.
Amazing.
What kind of music? What genre is it?
It's a sophisticated pop. Listen for yourself.
You've never hooked me so hard. Wow. I'm like
super curious, right?
Oh, thank you so much for coming on and sharing with us everything you've been working on and just educating the community in this space. It's moving fast, and so it's really valuable. Thank you so much, Chris. And thank you, Mike and Justin, for joining us, and chat for being here. We'll see you if you have the availability. We'll be around in a couple hours for our next episode or next Friday. But have a wonderful weekend, everybody, if we don't see you, and catch you on the next one.
Bye-bye.